When sizing conductors for a welder, understanding the National Electrical Code, or NEC, requirements is crucial. Article 630 specifically addresses welders. For the ampacity of supply conductors, the NEC dictates that you consider the primary current and duty cycle. Even if the welder operates at a low duty cycle at high amperages, the conductors must be sized to handle the full primary current continuously. Using the information provided, the primary current is 48 amps. You are correct in assuming that you should use the 100% duty cycle in Table 630.11. This means your conductor ampacity should be 48 amps. When it comes to the overcurrent protection device, or OCPD, sizing, the NEC allows for an OCPD up to 200% of the primary current. In this instance, 48 amps multiplied by 200% equals 96 amps. You mentioned using a 90 amp breaker. However, there's another factor to consider: the welding plug and cord rating. The welder uses a 50 amp plug and number 10 American wire gauge or AUG cord. According to the NEC, you cannot use a breaker smaller than the rating of the plug and cord. Therefore, you cannot use a 50 or 60 amp breaker. Based on this, you must use supply conductors rated for 48 amps and a 50 amp breaker. It is important to consult the welder's nameplate. If the nameplate specifies a specific OCPD rating, you must use that rating, regardless of the calculated value. The use of a 50 amp plug and cord on a 48 amp circuit is acceptable as long as the conductor ampacity is not exceeded. For clarification, let's further break down the reasoning and NEC guidelines that support these conclusions. Firstly, the conductors supplying a welder must be capable of handling the continuous load imposed by the welder. This is why the 100% duty cycle is used for conductor sizing, even if the welder is not constantly operating at its maximum output. Secondly, the OCPD is intended to protect the conductors from overcurrent conditions such as short circuits or excessive loads. The NEC allows for a higher OCPD rating for welders to accommodate the inrush current that can occur when the welding arc is initiated. Thirdly, the plug and cord are integral parts of the welder circuit and must be considered when determining the appropriate OCPD size. The plug and cord are rated for a specific amperage, and exceeding that rating can lead to overheating and potentially a fire hazard. It's also important to know that the conductor size should be appropriate for the 48 amp load and comply with NEC Table 310.16, which provides ampacity ratings for various conductor types and sizes. For example, using a copper conductor with a 75°C insulation rating, a number 8 AWG conductor would be suitable for a 48 amp load. However, the number 10 AWG cord to the welder is already determined at 50 amps. Now let's delve deeper into the specifics of conductor ampacity and OCPD selection. Conductor ampacity is the maximum current in amps that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. The NEC provides ampacity tables for various conductor types, sizes, and insulation types. The ampacity of a conductor is affected by factors such as the ambient temperature, the number of conductors in a raceway or cable, and the type of insulation. When selecting conductors for a welder, it is important to choose conductors with an ampacity that is equal to or greater than the calculated load current. In this case, the calculated load current is 48 amps, so you would need to choose conductors with an ampacity of at least 48 amps. Regarding OCPD selection, the NEC provides specific rules for sizing OCPDs for welders. As mentioned earlier, the OCPD can be up to 200% of the primary current of the welder. However, there are also minimum OCPD size requirements based on the conductor ampacity. The OCPD must be sized to protect the conductors from overcurrent conditions. This means that the OCPD must be rated at or below the ampacity of the conductors. In this case, the conductors are rated for 48 amps, so the OCPD must be rated at or below 48 amps, unless the 200% rule applies and doesn't exceed the plug and cord rating. The 200% rule allows for a larger OCPD to accommodate the inrush current of the welder. However, the OCPD must still be sized to protect the conductors from overcurrent conditions. Another important consideration when sizing conductors and octs for welders is the voltage drop. Voltage drop is the decrease in voltage that occurs along the conductor due to the resistance of the conductor. Excessive voltage drop can cause problems with the operation of the welder. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To minimize voltage drop, it is important to choose conductors that are large enough for the load current and the length of the circuit. You can also use conductors with lower resistance, such as copper conductors. Furthermore, let's address some potential scenarios and frequently asked questions related to welder circuit sizing. Scenario 1. What if the welder's nameplate specifies a minimum circuit ampacity that is higher than the calculated value based on the primary current and duty cycle? In this case, you must use the nameplate value for sizing the conductors. The nameplate value represents the manufacturer's recommendation for the minimum circuit ampacity required for safe and reliable operation of the welder. Scenario 2. What if the welder is used for both single-phase and three-phase power? In this case, you must size the conductors and oct based on the highest current draw for either the single-phase or three-phase configuration. This ensures that the circuit is adequately protected regardless of the power configuration used. Scenario 3. What if the welder is used in a commercial or industrial setting where there are multiple welders operating simultaneously? In this case, you must consider the total load of all the welders when sizing the conductors and oct. The NEC provides rules for calculating the total load of multiple welders based on their duty cycles and diversity factors. Frequently asked question number 1. Can I use a smaller breaker than the calculated value if the welder is only used for light-duty welding? No, you cannot use a smaller breaker than the calculated value or the plug-in rating, even if the welder is only used for light-duty welding. The oct must be sized to protect the conductors from overcurrent conditions regardless of the actual load on the circuit. Frequently asked question number 2. Can I use aluminum conductors instead of copper conductors for a welder circuit? Yes, you can use aluminum conductors instead of copper conductors for a welder circuit. However, you must use conductors that are sized according to the ampacity ratings for aluminum conductors in NEC Table 310.16. Aluminum conductors have a lower ampacity than copper conductors, so you will need to use larger aluminum conductors to carry the same amount of current as copper conductors. Frequently asked question number 3. What if the welder is plugged into a multi-outlet circuit with other equipment? In this case, you must ensure that the total load in the circuit does not exceed the rating of the circuit breaker. The NEC provides rules for calculating the total load on a multi-outlet circuit. If the welder is likely to be used at the same time as other equipment in the circuit, you may need to install a separate circuit for the welder to avoid overloading the circuit. Understanding the NEC guidelines for welder circuit sizing is crucial for ensuring electrical safety and compliance. By carefully considering factors such as primary current, duty cycle, conductor ampacity, oct selection, and voltage drop, you can create a safe and reliable electrical system for your welding equipment. The information provided here offers a general overview of welder circuit sizing. It's essential to consult the latest edition of the NEC and local electrical codes for specific requirements and guidance. When in doubt, always consult with a qualified electrician to ensure that your welder circuit is properly installed and meets all applicable safety standards. Furthermore, always refer to the manufacturer's specifications for your specific welder model. The manufacturer's instructions will provide valuable information about the electrical requirements of the welder, including the recommended conductor size, oct rating, and voltage requirements. By following the manufacturer's instructions, you can ensure that your welder is operating safely and efficiently. In addition to the NEC and the manufacturer's instructions, local electrical codes may have additional requirements for welder circuits. It is important to check with your local building department or electrical inspector to determine if there are any local codes that apply to your situation. Local codes may address issues such as the type of wiring methods allowed, the grounding requirements, and the location of the welder disconnect switch. By complying with local electrical codes, you can ensure that your welder circuit is safe and meets all applicable regulations. In summary, proper welder circuit sizing involves a comprehensive understanding of NEC guidelines, manufacturer's specifications, and local electrical codes. By carefully considering all of these factors, you can create a safe and reliable electrical system for your welding equipment. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you are not comfortable performing the work yourself. A qualified electrician can help you determine the appropriate conductor size, operating, and wiring methods for your specific welder and ensure that the installation meets all applicable safety standards. Staying informed about the latest electrical codes and best practices is essential for maintaining a safe and efficient welding operation. Regular inspections of your welder circuit can help identify potential problems before they become serious hazards. By taking a proactive approach to electrical safety, you can protect yourself, your employees, and your property from the risks associated with electrical work.